Hello again, everyone, and welcome to this year's KansasFest presentation on A2osX. I'm Patrick Klepfer, and we'll be presenting our team's development update, some demos, and with time permitting, we'll answer any questions you have. If you're unfamiliar with A2osX, you may want to watch last year's KansasFest presentation, which gave a good overview and went into the details about the configuration, booting process, memory usage, and how the whole system is put together. For those not already familiar, A2osX is a systems application sitting on top of ProDOS, providing a complete multitasking, multi-user operating environment for the Apple II. The core and many of its components are written in 65 C02 assembler, primarily for size and speed of execution. It does require and makes extensive use of 128K of memory in an enhanced Apple II. It can also be run on a 2C or a 2GS. It includes a comprehensive network stack and many utilities or apps, as well as an evolving set of development languages. Let's take a look at what's new. Last year, I covered many of the drivers that we have already made available. You will see several of these in use during the demos. New this year are grappler and parallel interface drivers to add printer support. And lastly, we are working on a PPP driver to allow you to connect your Apple to the internet with a Super Serial card and your own PPP server. We're still looking for someone who could take the Super Serial card driver and adapt it to work with the SCC chip found in the 2GS. And if anyone is familiar with the Mockingboard, we could use a hand finishing that driver as well. In our system programs group, or server daemons, is BBSD, a special telnet server that executes a chosen script upon connection rather than the standard Getty or login process. This is designed to be used with the new A2osX language, which I'll be demoing shortly. We also have a sys samba daemon to mount remote file systems. And lastly, NTP date, a daemon that uses network time to keep ProDOS time current. Or if you have a no slot clock, you can use it to set this time from the network, say once at boot up. New in the file management group is stat, which shows all the meta detail about a file, such as owner and last access time. Thanks to Bobby, we have new file processing utilities for numbering lines, hex dump, a stream editor, a disk usage reporter, and an Xargs command processor. There is a new uname command for reporting system information, such as the current version of the kernel or the build of the image you're running. And from Brian Bernstein, a tool for changing the state of your accelerator from slow to fast, programmatically or from the command line. From Cucumba, we have some new hashing commands for MD4 and MD5, and hash work he did needed to implement NTLM logins later this year. Lastly, Shutdown has received an update that I'd like to show you now. Here is our running system. Last year I discussed the boot process and how A2osX installs its own quick code or QC manager. This is used by Shutdown to exit A2osX and pass control to another program. Take Basic. We have placed a copy of basic.system in the bin directory and just called it Basic. This allows us to run it from the command line, and as you can see, when I type BASIC and execute it, A2osX determines that it is a systems type program, automatically shuts down all processes, unloads, and runs BASIC for us. Now at the BASIC prompt, I can just type buy, and you will see that our quick code system is reloading A2osX. This year, we have taken it a step further and added argument passing. Following the CC65 argv or ProDOS argument protocol, I'm going to change my directory to one where I've put some basic programs. And you can see I can list them out here. And actually you can see that they're of type basic. And I can execute any one of these by simply typing basic, and I have one called menu. Again, it will stop A2osX. It loads basic, but this time it passes basic.system, the name of the program to run, and it loads menu. This program has a by in it, so I can say exit menu, and again, it will exit that out and return you right back into A2osX. I mentioned earlier some of the updates in the networking or services area. Let's take a look at the new sys or Samba implementation that is being worked on. Okay, we're back in AppleWin with A2osX freshly booted. I'm going to start the network, loads the driver for the Ethernet card, loads our TCP stack, and in fact I can switch to the console and see that it's gotten an IP address. And then if I want to use sys, I use our new daemon and put in the server name or IP address of a Windows server or a Samba server, the name of the share we want to use, and a Protoss mount point, which is a volume name. And lastly, we tell it to run in the background. You'll see it's gotten a process ID, it's connected to the server, and it's mounted it as KFest like we instructed. We can change to that volume and do a directory listing. We can actually get a long directory listing. We can display the contents of one of those files. And it's putting it on the screen. And in fact, to show you that this is a live server, I have the same file open up on my Windows machine in Notepad. And I can come over here and add some text. I need to learn to type. And save it out. Well, let me fix that typo. And if we come right back over to our AppleWin session and repeat the last command, you can see it's added the extra text from the file. And in fact, I can switch now to both AppleWin and a 2E that has a Ethernet 2 card in it, connect to the same KFest share, go into that directory, and we'll show the contents of the same file. Back in AppleWin, I wanted to show you that we treat the sys file system just like it's a regular Protoss volume, and you can use any of the file commands or utilities on it. For instance, notice in that file we have KFest twice now. I can do a grep for KFest, and it will show me just those lines that are in there that meet the grep. Or we can edit a new file using the standard A2osX text editor. Save it out. And if we do a listing of our volume, we now see the new file, and we can dump that to the screen. Our long-term goal with SIFs is actually to connect this up all the way through to GitHub, where when source code is put on there and merged, and Apple can pull it down. It will be pulled down to a Windows machine with a Git sync, and then the Apples can pull it in, assemble the programs, and build packages, and actually be able to push them back out onto our A2osX update web server. There are 6 languages available or in development as part of A2osX. They are the shell, or SH, an assembler, or ASM, a C shell, CSH, fourth, A2os, a language used to create BBSs like GBBS, and a C compiler. The shell was the first language made available to users. It is interactive, and what gives you that iconic $ prompt. It is interpreted or parsed in real time, making it slower than an assembled program, but it is robust, as you can see from the word list. You have full support for loops, conditional execution, and even functions. In fact, all the testing I do, the media creation for use with AppleWin, your CFA, or Booty, and building update files, are all done through scripts. If we move back to AppleWin, I can show you some of these scripts. One of them is ADM, or A2osX Domain Manager, really an administrative script that all it does is call other scripts. The reason I did this is so I could put one file in the bin directory that could then call as many as I needed to, not filling up bin, which is searched every time you enter a command. So if I type ADM and press return, it'll actually tell me I didn't put in an argument. And one of the commands it takes is update. And what do we want to update is A2osX itself. We are planning to expand this to be able to update packages or other software. It will run the update utility, and you'll notice it comes back with an error right away. The network wasn't started. That's one of the things the scripts do, is it tries to do as much error checking as possible. So I'll go ahead and start the network as we had done before. And now I can quickly check, make sure we do have an IP address. I can use the up arrow for going through the history and run that command again. And we'll see it again. It will get past the check for making sure the network's loaded. And it's telling me my system is already up to date. There's actually an option to force to re-update to the latest version in case your machine is corrupted or something. A moment ago, I showed using the arrow to go through history, and you can go up and down. There's also a new feature. You can press the tab key, and it will show you the last 10 items of history. And if I hit tab again, it gets out of that. Let me quickly show you the admin script. As you can see, it does some checking to make sure you pass it the right kind of parameters. It then checks that there aren't any leftover files in the temporary directory from, say, a previous run of this. And it uses the HTTP GET utility to go out to the web, download the latest version, a file that has in it the latest version number, and then it can compare that to what's in your system. And you can see again, this is where it checks that the network's loaded, if it can't reach the server, etc. If it does work, it will download the update itself. In that it figures out the file name for the update, and then it will unpack it onto your system. In addition to the admin system, we're adding help. Again, I didn't specify what I wanted help on. You can get help on help. You can get help on utilities like edit, or you can actually get help on, say, not just the shell, but how to use the shell cd command. The help is being added to on a daily basis, and we hope by the release of 9.4 we'll have help for all of the languages and all of the utilities. The next language we added is a full macro assembler, which is based on the assembler from SC Systems. You can now edit, assemble, and run programs all within A2osX. In fact, Bobby did her development of OD, NL, Xargs, and SED this way. The assembler is capable of creating both standard ProDOS system files or the bins executable by A2osX. And moving back to AppleWin, I can show you the typical Hello World program. In fact, if I type it here, you can see it says Hello World, and then I can edit it. And we've provided a template for you for building bins compatible with A2osX that does some of the things like the relocation table, making it re-entrant, multitasking, etc. I'm going to move to the bottom of this assembler source, which a lot of you might recognize. I certainly won't. And I'm going to change the hello world string to say KansasFest. Save our file. And then we'll go out to the command line and assemble it. Loads the assembler. There are macros that have already been written for you that contain a lot of the APIs for calling the built-in libraries of A2osX. And now if we run that same program again, you'll see that it says KansasFest. The next language the developers added to A2osX is the C shell, which is interpreted like the regular shell, but it has more data types, and as you can see, it has access to the C-typed APIs in A2osX. I expect as we get further along in the development of CSH that most of the administrative scripts will be rewritten to this because they'll have so much more access to the APIs and to be able to call other programs. If we switch back to AppleWin, I can show you a C shell script, and it should look very familiar to anyone who's developed in C, or if you use C shell on Linux systems. And you can see here it has defines, access to other types, standard printf, puts, ifs and blocks of code. If I exit it, I can run this for you pretty quickly. And that's actually it for C shell now. It's being used primarily as a tester of all of the APIs that were assembler only, if you will, and that have been converted to the C calling spec, preparing us for the C compiler, which I'll be talking about in a little bit. Next is an implementation of Forth based on the Forth 79 language, which was started earlier this year. As you can see from the word list above, it is a very extensive, if not obtuse, language. I believe someone has even written an operating system for the Apple II entirely in Forth. Our implementation uses a compiler at runtime to create fast machine code, and when compared with our DHGR driver, you can create stunning graphics in A2osX. Let me switch back to AppleWin and show you what a script for generating Mandelbrot looks like written in Forth. So let me display for you the Mandelbrot script. And one of the things I want to point out is that top line, which starts with a pound bang, which tells the system, hey, this is going to be a script, and here's what language or scripting engine to use, in this case, Forth. And as I said before, our Forth implementation uses a just-in-time compiler at runtime. So when I go to execute the script, it'll compile it first and then start running it. Because this is a graphics demo, I'm going to load our graphics driver into the system, and then I'll start the Mandelbrot process. And here you can see it displaying standard picture. When it's done, the system will return us right back to where we were. You can switch back and forth. We're at our virtual terminal. There is a virtual graphics terminal that you can get back to by hitting Alt-9, just like you could hit Alt-0 to go to the console. A2os, a basic-like language and compiler used to create GBBS. The original A2os compiler was really just a tokenizer, where the A2osX implementation uses the same just-in-time compiler as Forth. When a script first loads, it takes a moment to compile, but then actual execution is quite fast. We are considering a caching mechanism to save these compiles for subsequent executions of the same script. As you can see from the word list, we're pretty close to a full A2osX basic compiler down the road. In combination with this new language, we have added a special BBS daemon that I talked about before that can be loaded, which will listen on any configured port you decide, and will run an ACO script, or really any A2osX program you specify when a user connects to that port. I have my real Apple IIe running an ACOS demo script that we can telnet into. I've switched back to AppleWin so I can use A2osX and its built-in telnet client to connect to my Apple IIe, which is running the BBS daemon. You'll notice I'm using special port 6599. That's what I've configured on the Apple II. You could just as easily use the standard telnet port 23 or any other port if you're trying to get around firewalls or what have you. I'm going to press return. It's going to connect to the system. And you notice there's a little pause here. As you saw the ACOS come up, it compiled the script and then presented it to us. I can type in a name now. We get a welcome. We can ask to display the menu, the status information about the system, the latest news, and then I exited. The socket 27 is because I exited, the script finished, and the telnet daemon, BBS daemon rather, automatically kicked me off. If I want to go back in, I can just hit it again. Again, it's loading ACOS. It's doing a quick compile, and it's presenting us with the script. Our next major language endeavor will be a full C compiler that will produce standalone programs or bins. Over the last year, a lot of work has gone into updating all the internal A2osX APIs to make them compliant to C calling conventions. As I mentioned earlier, the C shell was actually created as a testbed for using and testing the new API format in preparation for the full compiler. I have mentioned several times all the APIs that you can use to write programs in A2osX. All of these are available today for programs written in assembler. In fact, all A2osX bins make great use of them. Making them available via C shell and C expand their access and use to more programmers. This slide shows only part of what's available, but you can see there are APIs covering kernel processes, such as allocating memory blocks, doing math, both integer and float, I/O APIs for working with files and streams of data, ones for manipulating strings and time, and a full library for dealing with networking. S-lists are a special brand of API or category and are worth calling out here. This is a symbol list API used by all the languages to manage unique symbol parsing and holding their value. Where you have constants or vars or even the functions in shell are symbols, the name, and their value. These are all stored in auxiliary memory. There's even a trick in shell where you can have a script call another script of just functions. They all get loaded in auxiliary memory, but then they run like they are in the main body of your master script. This means they don't take main memory. Even the assembler uses S-lists to utilize auxiliary memory so you can write larger programs. By the way, the A2osX assembler is table-driven, so it can assemble code for any processor if you give it the right table. Tables for the 65XX and even the Z80 are included with A2osX. And if you wanted to, you could provide it tables for others, such as the 68000 or 8080. If you want to find out further information about A2osX, you can go to our GitHub page. We have a website, a Facebook page, Twitter, and we are most active. In fact, there are many developers of A2osX and users of it on our Slack channel. We even have a free node test IRC site for people who are using our IRC client. Now, in whatever time's remaining, I'd be glad to take any questions and see if we can get you answers, or we can follow up later in either our Slack channel or the Discord server.